particular session we will be looking into how to design a design a PDA for the given language. So the question states like this: design PDA to accept strings of balanced parentheses. The parentheses could be simple, square or curly parentheses. So we need to have a balanced parenthesis in the sense when you open a parenthesis, the other parenthesis it should be closed. So we have simple, square and curly parenthesis, and this has to be a balanced parenthesis. So we will see an example for balanced parenthesis as well as imbalanced parenthesis. So if you have a string like this, this states that it is a balanced parenthesis, because if you open this square parenthesis, you are closing it, this also same thing and this also, so it is a balanced parenthesis. So we will see an example for imbalanced parenthesis. So I can say this is not a balanced parenthesis because this has been closed before you are closing this square parenthesis. So this kind of strings should not be accepted by the language or by the PDA. This kind of strings should be accepted. Now we will try to understand how to solve such kind of questions. So here they have not mentioned the order of the parenthesis. Either you can have a simple parenthesis, square and curly, but it has to be a balanced parenthesis. So here when you receive curly parenthesis as the first input symbol, your stack will be having Z0. So you should simply accept it. What if your first input symbol is a simple parenthesis? Again you have to accept that parenthesis as well. What if it is square? So square also has to be accepted. So you need to, whenever you are trying to solve such kind of problems, you need to see the different kinds of possibilities. What can be the first element, what can be the second element, and so on. So by looking at this example, we can see a simple parenthesis can be the first input symbol, then you can have a curly parenthesis, then you have square. So this is the given input string in the question. So we will try to see how it works in the stack so that writing the PDA would be easier. Writing the PDA for this string would be easier. So you are reading simple parenthesis and Z0 is in the stack. What do? You just push it into the stack. And again you have opening curly parenthesis, opening curly braces if you have, and stack is having a simple parenthesis, you simply push it onto the stack. Square braces, so you simply push it onto the stack, because curly you need not worry about what are the input symbols. So while you are popping, so when you are looking at the closed parenthesis, so that is where it is important to have a balanced parenthesis. So when you are having a closing parenthesis, then you have to worry about popping and what is there in the stack. So if you are reading the opening parenthesis, you need not worry, just keep pushing onto the stack. So now you are reading close square parenthesis. When you are reading a square braces which is closed, you have to see the corresponding opened element in the stack. Then only the string will be balanced. So if you are reading square braces, closed square braces, you have to read a open square braces in the stack. Then only the string is balanced. So next you are reading a curly closed parenthesis. What should be there in the stack? The corresponding opened curly braces. So you are popping this out. Next, again you are reading a simple closed parenthesis, you have to read a corresponding open parenthesis in the stack. Yes, we see that. So, this also will be popped out. This also will be popped out. Next, you reach the empty string, the end of the string. You reach the end of the string. So, when you reach the end of the string, in the stack there should be Z0 only. There should be Z0 only. So, this is a simple example which we have taken, and we have seen how it should work. So, let me take one more example that does not belong to the language. Say for example, this string. So, this is a simple string which is not balanced, which should not be accepted by the PDA. So, what do you do? So, opening, as I said, for opening all opening parentheses, just push it into the stack. Whatever is there in the stack, you need not worry about it, but you have to write the all possibilities that has to be accepted. So, I will tell you when we are designing the PDF for it. So, open, just push it, open, again just push it onto the stack. Now, you are reading closed curly parenthesis. So, if it is a balanced parenthesis, what should be there in the stack? It has to have a open curly braces. But what is there in the stack? We have opened square braces. So, this should not be accepted. So, we cannot pop this because we do not have a corresponding opened curly braces in the stack as the top stack element. So, this is not a balanced parenthesis. This is not the balanced parenthesis, and we get stuck here, we will not go further. So, this will not be accepted by the PDA. So, we will look into how to design the PDA for the same. So, we will start with the state Q0. Now, we can have simple or open square or open curly as the first input symbol. So, we will try to accept all of these and push it onto the stack. As I said, for opened parenthesis, you just need to push it onto the stack. So, we will perform that operation. Open parenthesis should be the input symbol and stack will be empty initially. Stack will be empty initially, which is Z0, and you will simply push simple open parenthesis into the stack. Similarly for square, you will simply push it onto the stack, and similarly for curly, should be pushed into the stack. So, whichever is the first input symbol, you have to accept it. So, you have accepted by using these three transitions. Next, you might have opened simple parenthesis in the stack. You might have opened simple parenthesis in the stack, and again you might get this or this one as the input symbol. So, how will you write the transition for it? Your input symbol is open parenthesis and stack you will have open simple parenthesis itself. You will simply push it onto the stack. As I said, whatever comes as the input symbol and your input symbol is simple open parenthesis, you simply push it. Onto the stack. So, we will write all the three possibilities. Your square open parenthesis can be the input symbol and simple open parenthesis. So, you will just push it onto the stack. Same for curly. When do you pop? You have to remember that. When do you pop? When you start reading the closed parenthesis. Then only you start popping. So, try to accept all possible input symbols with the stack symbol. So, next you can have square also in the stack and you can have simple square and curly as the input symbols. So, what will you do? You will write those three possibilities also. You will simply push it onto the stack because all are opened parentheses. We will simply push it onto the stack. Next, you can have curly parentheses in the stack and these can be the input symbol. Again, you have to push it onto the stack. So, we will write those transition as well. Your current stack element is curly, accepting simple open. So, just push it onto the stack. Now, you have seen all the possibilities. So, in your stack you might have open, simple, curly or square braces. When you are having open parenthesis as the input symbol, you will simply keep accepting it and pushing onto the stack. Your stack will have the memory of all the open parentheses. Now when you start reading the closed parenthesis, what do? So, when you start reading the closed parenthesis, as I said, the top stack element should be the same element as your closed input symbol. So, now if this is the closed input symbol, what should be there on the stack? Top stack should be having the open. If it is closed simple parenthesis, your top stack should be having open simple. Your top stack is closed, sorry, your input symbol is closed curly, then your top stack should be opened curly parenthesis. So, this you have to keep in mind. So, now we will write the transitions for these. Should we stay in the same state or should we change the state? So, you might have strings like this. So, when this kind of strings come, you can have a close parenthesis and then you can read a open parenthesis. So, what will you do? You will stay in the same state, that is Q naught. You will stay in the same state Q naught. So, we will write that transition. We will write that transition in the state Q naught itself. So, if your input symbol is closed simple parenthesis, stack should have open simple parenthesis itself. Then you will pop it. So, in the balance parenthesis you will have such kind of representations. So, next square only, pop it. Curly closed, curly open only, closed, pop it. So, and you will stay in the same state because after accepting a closed parenthesis, you might accept a open parenthesis as well as the input symbol. So, you will stay in the same state Q naught. Hope this is understood. Next, we will look into reaching the end of the string. So, when you reach the end of the string, stack should be empty and Z naught should be the top stack element, because already we have seen in this example, when you reach epsilon, you have to have Z naught is in the stack. So, now epsilon is the input symbol and stack symbol should be Z naught. So, upon Z naught you reach the final state Q1. So, this is what is the transitions for the set PDA. The language said that it should accept balanced parenthesis. So, this will accept balanced parenthesis. I hope you can write the transition function for the same. Looking at this, if you want me to write, I can write it. You can write the transition function for the same. So, I will just write it for few of the transitions. You can write for the rest of that. So, delta Q naught is the input symbol, current state, and you are reading open parenthesis, Z naught is the stack element. So, what do? Stay in the same state and push it onto the stack. And so on. So, finally, accepting all the strings, when you reach the pop element, so Q naught and there is a closed parenthesis and open should be there in the stack, this is mandatory, and you will stay in the same state, but you will perform pop operation. So, this is what we are writing now. Q naught, closed is the input symbol, open is the stack element, you will simply pop it. So, same thing for the next one. Q naught, closed is the input symbol, open should be the stack symbol, and you will pop it. Q naught, closed curly, open curly, and then you will pop it and stay in the same state. Finally, reaching the final state, Q naught, epsilon, Z naught should be the top stack element. We are writing the transition for this one. You will reach the final state Q1 epsilon or Z naught. Q1 Z naught, you have reached the final state, and this is accepting by final state method. If you are accepting by empty stack method, use epsilon, that is popping. So, next, writing the instantaneous description for the string, sequence of moves made by the string, this one. So, this is the string given in the question. We will write the instantaneous description for this particular string. So, how to write it? So, you have Q naught and the input string whatever is there, just write it down, and what is the top stack element, that is Z naught. So, what do you do? Q naught will read open parenthesis and Z naught is the top stack element. So, based on this particular transition, you will simply push it onto the stack. Q naught, the remaining string is, you just write down the remaining string and push that onto the stack. So, this is how you write the instantaneous description, or in the question they might ask you to show the sequence of moves made by the string. So, here Q naught is reading square and input symbol is open parenthesis. So, based on this transition, you will simply push it onto the stack. The remaining string is, so you will just write down the remaining string and push that onto the stack. So, next, Q naught is reading curly braces and square is in the stack. Upon this transition, you will simply perform push operation. Remaining string, push that onto the stack. Now, next, Q naught is reading closed curly parenthesis. What did I say? It should have open curly parenthesis in the stack, then only it can be accepted. So, according to this particular transition, we will perform a pop operation. Q naught, the remaining string is closed parenthesis and you will pop this. So, you will remain with these two symbols on the stack. Next, you are reading a closed square parenthesis. Open square should be in the stack, yes. So, we do have it. So, based on this transition, we will be performing Q naught will be staying in the same state Q naught, closed, this will be popped out and remaining will be this in the stack. Next, again Q naught is reading closed, open should be in the stack. So, Q naught epsilon, this will be popped out, remaining will be Z naught. So, you will reach final state from this Q1 epsilon Z naught, Q1 epsilon Z naught, because you are accepting by final state method, write the same thing Q1 epsilon Z naught, you have reached the final state. So, the string will be accepted. So, this is with this example balanced parenthesis.